In this video, we're going to be covering 1.6, describing pairs of angles. So last chapter, we looked at how to look at just different types of angles. We had acute angles, obtuse, straight. But this one, we'll actually start to talk about them together, pairs of angles. And so we'll be looking at complementary and supplementary angles, and then we'll also be looking at some new vocabulary of linear pairs and vertical angles. So complementary and supplementary should be somewhat familiar to us. Usually we should have learned this before geometry. Complementary angles are when we have angles that add up to be 90 degrees. They don't necessarily have to be right together like in this first example where it shows them in the same angle. It's just an angle that's been divided into 1 and 2. But we can also have them where they're just two different angles, two separate angles. Like this one, we have angle A and angle B. But together they add up to be 90, so they are still considered to be complementary angles. Supplementary is the same exact thing, except for now we're looking at sum of 180 degrees instead of 90. So when we look at these types of angles, one thing we'll see in problems is the word complement and supplement. So if I am told that an angle is a complement of another angle, that just means together they are complementary. Same thing if it's a supplement of another angle, that means together they're going to add it to be 180 degrees. So another one that we have is adjacent angles. Adjacent angles are two angles that share a common vertex and a side. Okay, so they have to be right next to each other. Adjacent means beside each other. So they share that same common vertex, as it shows here in this diagram, and one common side. Okay, if they are separate angles, then they are non-adjacent. So in this first example, we want to first name a pair of complementary angles. So complementary, we would say it adds up to be 90 degrees. So if I look at these, first I have one that's 127, I have this 37, and I have 53. So looking at that, I would think this 37 and 53, so if I add that up, 37 plus 53, it does give me 90. So that would mean those angles would be complementary of each other. So angle A, okay, but if we notice, angle A would refer to two angles, so I have to call it by three letters, so I'm going to call this RAC plus the angle of RST, or angle S, would equal 90 degrees. So I could also say that they are complementary. Then we want to look for supplementary angles. So supplementary means that they add up to be 180 degrees. So if I notice, well, these two aren't a straight line. Okay, so they can't be supplementary. They don't have to be a straight line, which would be 180. So odds are it's going to be the 127 plus 53. So if I add that together, it does give me 180. So that would mean those two angles are going to be my supplementary. So that would be angle CAD plus angle RST would equal 180. So I could say that they are supplementary. And then we also want a pair of adjacent angles. So remember, adjacent angles mean that they have to share a common side and they have to share a common vertex. So if we look here, this angle over here, RST, is all alone. It's by itself. So it can't be adjacent to anything at this moment in time. It doesn't have an angle next to it. But if we look at this one over here, we have a common vertex of A, and we have a common side of ray AC. So my adjacent angles would be those two. We would have angle RAC and angle CAD. And they are adjacent. Notice that adjacent angles don't have to equal anything. They can be any kind of sum. They could be supplementary or complementary, but they don't have to be. They can add up to be some other number. So now we're going to look at another problem. We have example 2, where we're going to have some word problems. So in A, it tells me that angle 1 is a complement of angle 2. So complement means 90 degrees. So if I wanted to know what this would look like, I would know I would have a right angle. if I wanted to draw them together. I would have some ray down the middle, and so this one I could call angle 1, and this one I could call angle 2. It tells me the measure of angle 1 is 62 degrees. So if I want to find angle 2, well, I know they're complementary of each other, so I can subtract from 90. So 90 minus 62 would give me 28. So that would mean the measure of angle 2 is equal to 28. With B, now I'm talking about supplement. So supplement means they're going to be on a straight line, and they're going to have some dividing ray in between them. So angle 3 is a supplement of angle 4. So angle 4, it tells me, is 47 degrees. So I'm looking for angle 3. So now I'm just going to subtract from 180. So 180 minus 47, which should be 33. So that would mean the measure of angle 3 is equal to 33. Okay, so complement is 90, supplement, I should automatically think 180 degrees. So we're going to look at another type of problem, example 3. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. So it wants us to find the measure of BCE. So that means over here I'm going to have the measure of BCE is equal to blank. And it wants me to find the measure of ECD. So those are the two I'm looking for. Notice I'm not looking for X. Now I'm going to have to solve for X, but that is not what the problem is asking for. Do not stop just at finding X. Make sure we're answering the question. So when I look at this, it told me that they are supplementary, so that means they're 180 degrees. So if I add them together, they should equal 180. So that's what I'm going to go ahead and write. I'm going to write the measure of angle RC, and then my other point out here is E, plus the measure of ECD would equal 180. Then I can just substitute it in. It's very important to be sure to be able to write these types of equations out and then supplement. And then just plug in so that way you know what you're solving. A lot of times we want to jump ahead and just plug things in, and then we get confused on our equation. So go ahead and write out what you know. So I know if they're supplementary, I can add them up to be 180. So then I can look back, and RCE is 4x plus 8 plus ECD is x plus 2, so that equals 180. I'm going to combine like terms, so I have 4x and x here. I have a plus 8 and a plus 2. So 4x plus x gives me 5x. 8 plus 2 gives me 10. It's still equal to 180. I need x by itself, so I'm going to move this constant over. When I move across the equal sign, I do the opposite. So I'm going to subtract 10 from both sides. I get 5x is equal to 170. I need to get x by itself, so again, I'm going across the equal sign. I do the opposite. So the opposite of multiplication is division. So I divide by 5. And so that'll give me x is equal to 24. My mistake, 34. 5 goes into 17 3 times. So x is equal to 34. Remember, we are not solving for x. That's not what the problem asks for, so I am not done. I need to plug this back in. I'm going to substitute. So when I'm looking for BCE, and I just noticed that my picture was just cut off over here. So this was actually supposed to be a B over here. So you can go back in your work and you can change this. So BCE is the first one I'm looking for. So BCE is equal to 4x plus 8. So the measure of BCE is 4x plus 8. So now I know what x is, so I'm going to plug it in. So 4 times 34 plus 8. So then I'm just going to keep simplifying. So I get 136 plus 8. And so I end up getting 144. So up here where it said the measure of BCE, I get 144 degrees. Then I need to do ECD. So ECD looks like this other side over here, ECD. So the measure of ECD is equal to x plus 2. So I'm going to substitute in again. So this is equal to 34 plus 2. So it ends up giving me 36. So when I go back up here, I can put that it was 36 degrees. So obviously if I add this back up, it should be supplementary, and if you add 144 plus 36, you get 180, so that's just a way to check your work, and so odds are we got this correct. So then we have two more types of angles. We're going to talk about linear pairs and vertical angles. A linear pair is when the non-common sides are opposite rays. So basically, linear pair, they're always going to be supplementary because they have that straight side right here. And we know that a straight line always has the measure of 180 degrees, so it's a straight angle. And so a linear pair means they're supplementary, but they also have to be adjacent. Okay? So whenever they have this common side over here, it makes them adjacent angles, like we just talked about. And then they also add up to be 180. So one thing you can think about is a linear pair is always supplementary. But supplementary angles don't always have to be necessarily a linear pair. We can split supplementary angles apart. And then we also have vertical angles. Vertical angles are when we pair up. So we have two sets of opposite rays. So basically we just have intersecting lines. And so a linear pair is going to be whenever they are opposite of each other on these intersecting lines. So 4 and 5 would be a linear pair. And then also 3 and 6 are a linear pair. One thing to notice here is I put one line on 4 and 5 because they are equal to each other. Vertical angles are always equal. And then on 3 and 6 I put 2 lines because those would be equal as well. So in this example 4, we want to identify all the linear pairs and all the vertical angles in the figure. So first let's think about linear pairs. So for linear pairs, we have to have a straight line, and then they have to be angles that are together on that straight line. They also are just a pair, so we can only have 2 angles. We can't have 3 different angles added together, or 4 or 5. They have to be 2 because they're a pair. So let's start with a straight line. When I see one here going across, so on this side I have 180 degrees. There's only 2 angles there, so I could say angle 1 and angle 4 would be a linear pair. On the other side I have several different angles. If I had letters on these, I could possibly just pick one ray and say that angle 2 and angle 3 and 5, if I could call them by one name right now, I could say those are a linear pair, but since they only gave us the numbers names of them, we can't really list those right now because we can't do it as a pair. So let's look for another straight line. I have this line going this way as well. And here we have 180 degrees. On this side we have 180 degrees. On the top I have 3 angles again, so we're not going to worry about that because that doesn't make a pair. But on the bottom I do have 2. I have angle 4 and angle 5. And then those are the only 2 straight lines. This other line doesn't continue, it stops. Now if it did continue, then I could possibly have some more angles that I could name, but I don't at this time. So one last thing to remember on linear pairs is that since these 2 sets are linear pairs, that means they are also supplementary. So if I were to add angle 1 and angle 4, if I change this to an addition sign, they would equal 180. Same thing for 4 and 5. They would equal 180 degrees. So then we're going to move on. We're going to do vertical angles. So vertical angles in this figure, remember they are made by 2 sets of intersecting lines. So I'm going to go ahead and identify those lines again. I have this line here that's a straight line going through. And then I have this other line that is a straight line going through. So vertical angles have to be made by 2 intersecting lines, and they have to be opposite of each other. So in this case, if I name vertical angles, I could do 1 and 5 are vertical. So angle 1 and angle 5. Then going the other way on my two intersecting lines here, I would have angle 4, but then I would have angle 2 and angle 3. Okay, so I could say that it would have angle 4 and this would be like angle 2 plus angle 3. Okay, it would be vertical to angle 4. Okay, the reason I do go ahead and point this out is vertical angles are congruent. So in this case, I would have angle 1 is equal to angle 5. And then I would have angle 4 is equal to angle 2 plus angle 3. Okay, because if I added angle 2 and 3, they would make that big angle, and it would be equal to the whatever the measure would be of 4. So let's go ahead and put some just numbers on here. So we're going to pretend that we were given the measures of these. So say that angle 4, it looks like it's bigger than 90, so I'm going to go ahead and say it's 120 degrees. I'm just going to throw a number in there. If I told you that angle 2 was 70 degrees, then we could solve for angle 3 because 2 and 3 would have to add up to be angle 4. So if I plug this in, I would have 120 is equal to 70 plus angle 3. Well, to solve for angle 3, I would subtract 70, and so I could solve to get it, which would give me the measure of 50 degrees. Okay, those are things that we could see. Same thing goes for the other way. If I gave you the measure of one of these other angles, say I gave you the measure of angle 1 and it was 50 degrees, then if angle 1 is equal to 50 degrees, then that would mean that angle 5 is also equal to 50 degrees because it is a vertical angle and they are equal to each other. So then we're going to look at a word problem. Two angles form a linear pair. So linear pair, we know they have to be on the same line. So we can go ahead and draw this line. It would look like two opposite rays. It's going to have a vertex here, and it's going to have a ray going out on it. The measure of one angle is 5 times the measure of the other angle. So we're going to give one angle a measure of x. And it tells us that the other angle is equal to 5 times that angle. So 5 times x. So find the measure of each angle. Okay, so if we given these variables, then we know it's a linear pair. Linear pair means 180 degrees. So I can add them up. So 5x plus x would equal 180. I can combine like terms, so this would give me 6x is equal to 180. Solve for x, I divide by 6. So x is equal to 30. But it asks for the measure of each angle, so if we say this is angle 1 and this is angle 2, we're going to go and say angle 1 is equal to 30 degrees. Angle 2, we would have to plug it back in, so 5 times 30 would equal 150. So angle 2 would equal 150 degrees. Okay, these are the types of like word problems you'll see. You'll also see problems where it tells us that we have angles that complement each other. Remember, complement means it's going to be 90 degrees. So if I go back on this, and instead I change linear pair to complement, so I've gone back and I've changed it. Two angles are a complement of each other. Now that would mean that these angles have to add up to be 90 degrees. So if I again call them angle 1 and angle 2, angle 1 plus angle 2 would equal 90. The measure of one angle is 5 times the other. So again, I'm going to have, say I call angle 1 x, then angle 2 is going to be 5 times x. And it still equals 90. I combine like terms, so I get 6x is equal to 90. And again, we could solve this just like the other one, go back in and plug it in. Same thing would happen if I say they're a supplement of each other. Okay, so these types of problems, remember when I see complement 90, supplement 180, linear pair 180, we just need to know these vocabulary words as we move forward. So one last thing I just wanted to go over before finishing up is just looking at a diagram. There are some things that we can assume and we can know whenever we look at something, but there are some things that we cannot. Many times you'll hear me say that things are not always drawn to scale. Just because, like in this diagram, just because DBA looks like a right angle, I can't conclude that. Okay? Unless the problem tells me it is a right angle, this would be incorrect to assume. Okay? It looks like it, but it may be 89.5 degrees, which isn't 90, and it does not make it a right angle. It could be really close, but not exact. Some other things are that I can't assume things are equal to each other. So just because DBE and EBC look very similar, they look like they could be really close to the same, unless the picture tells me or unless the problem with it tells me that, I cannot assume these things, okay? If you start assuming things, you're going to get things wrong. You're going to end up missing the information that was important. Okay, so again, I encourage you, make sure you have this kind of diagram down. Be sure you're taking adequate notes whenever you bring them to class. And this is the last lesson for this chapter, so make sure you're going back, and we'll be having a chapter test soon over all of this. If you have any questions, be sure you're bringing it into class.